Today's lesson is going to deal mostly with function notation and something new called compositions. We've already done this problem where if we want to find d of 7 where we know d of x is equal to negative 4x plus 8, we take and do a substitution, basically plugging this 7 in for every x in the function. So d of 7 is equal to negative 4 times 7 plus 8, or negative 28 plus 8, which is negative 20. Nothing new. Now, let's say we have two different functions. We have some f of x function equaling 5s plus 6, and some g of x function equaling 2 minus x. So this is like y equals this, or y could equal this. Now, what we want to do is we want to find f plus g of x. Basically, what that's asking us to do is add the two functions together and tell us what the answer is. So in this case, we have 5x plus 6, and we're going to add to that 2 minus x. Pretty straightforward. So we end up with 4x plus 8. Likewise, f minus g of x is the same as taking the g function, subtracting it from the f function, so that's 5x plus 6 minus the quantity of 2 minus x. Don't forget to distribute the negative to both terms, so I have 5x minus a minus x, which is plus x, or 6x, and 6 minus 2, which is 4. F times g of x, here they just want us to FOIL these together, so 5x plus 6 multiplied by 2 minus x, I have 10x minus 5x squared plus 12 minus 6x, and then I combine like terms, negative 5x squared plus 4x plus 12 gives me f times g of x. This is a little different. They've separated these guys. They want us to take 3 times the f of x function plus g of 2x, which means plug 2x in for every x. So 3 times the f of x function, and then add that to, we substitute 2x in for every x in the g function. So that's 2 minus, instead of x, I now have 2x. This gives me 15x plus 18 plus 2 minus 2x. Add your like terms, I get 13x plus 20, and we're done. So in this case, we have the same two functions, f of x and g of x, and they want us to find f divided by g of x and indicate any restrictions on the domain. So we'll talk about that once we do it. First of all, it's just putting the f function over the g function. Now, when we talk about the domain of a rational expression, we take a look and say, okay, we haven't graphed these yet, but we know that in fractions, the only thing that is bad for a fraction is to have a 0 in the denominator. So if I were to have 0 in the denominator, this function would be undefined. So in order to find out a restriction on the domain, we say what sets denominator equal to 0. Well, to find out, we take that denominator, set it equal to 0, and solve. So 2 is equal to x. Therefore, my domain is all x's not equal to 2. Any other number will work. So let's talk about compositions of functions. Usually when you talk compositions, we're talking about more than one function. And when we find answers for compositions, we take the results of one function and use those to evaluate another. In this case, we're going to find f of g of 3. So let's write out how you'd say this. F of g of 3. There's no multiplications here. And that's also written as f composed of g evaluated at 3. Same thing. Typically, I like writing it this way. You'll see some books writing it this way as well. So I'm going to use an order of operations concept to kind of solve this. If you notice, what's inside the parentheses is g of 3. We do that first, and then we take its answer and evaluate the f function at that answer. So f of g of 3 is basically taking a 3 and plugging it into this x. So that's 3 plus 5. We take that answer, which is 8, and now evaluate the f function at 8, which is basically 4 times 8 plus 2, or 34. And we can do that for any set of numbers, variables, what have you. Let's do it again, except in a more general case. We'll evaluate f of g of x. There's no number in this case, so what it's saying to do is take the whole g of x function, substitute it in here, and then evaluate f of that value. So, for instance, f of, well, the g of x function is just x plus 5. And now it says take this x plus 5 and substitute it in for every x in the f function. So we have 4 times the quantity of x plus 5 plus 2, or 4x plus 20 plus 2, or 4x plus 22. Next, we're going to calculate g of f of x. Now, in this case, the f function is inside the innermost parentheses, so I will do that first. So we'll find g of, and instead of saying f of x, we're just going to say 4x plus 2. So I'm going to take this 4x plus 2 and substitute it into this x value in the g function. So that's 4x plus 2 plus 5, or 4x plus 7. This function is a little more difficult. It says evaluate the g function at a plus 6, multiply it by 2, and then plug that value into the f function. So let's do this first. This says f of 2 times, I'm going to find g of a plus 6. So I'll plug in a plus 6 into that x, and then add 5 to it. So now I have f of 2 times the quantity of a plus 11, which is f of 2a plus 22. And now I'm going to plug 2a plus 22 into the x value on the f function. So this is 4 multiplied by 2a plus 22 plus 2. This is my value of the x here that I'm substituting. I have 8a plus 88 plus 2 is equal to 8a plus 90. So here's a little bit different spin on the compositions. We have two functions f and g, and these functions are represented by a set of points. Remember, in these set of points we have x's and y's, and we know f of x is basically the same thing as y. So these are my inputs and my outputs, and we want to find compositions. The first is f of g of negative 5. So I go to the g function first, find the input of negative 5. this -5 outputs 0. So therefore, g of -5 is equal to 0, and now I have to find f of 0. Well, I go up to my f function. Notice that here is an input of 0, and I have an output of 3. So f of g of -5 is actually equal to 3. Likewise, if I want to find g of f of 1, I go to the f function and look for a value of 1. I look for its output, which is 6, and say now I have to find the g value evaluated at 6. I pop that 6 into the g function, get an output of 1, and g of f of 1 is actually equal to 1. You just have to follow the order of operations with respect to the functions. Do the interior first, and then do the outside. That's all we've got for today. Make sure you do your ConnectEd and your survey, and we'll talk tomorrow.